Section 6.6 is function operations. Our goal is to combine standard function types. On page 467, we have the final cost of the sofa in the solvent involves two functions, one that gives an additional discount and one that multiplies to find the sales tax. You can add, subtract, multiply, and divide functions based on how you perform these operations for real numbers. One difference, however, is that you must consider the domain of each function. For addition, we have f plus g of x is equal to f of x plus g of x. Subtraction, f minus g of x is equal to f of x minus g of x. Multiplication, f times g of x is f of x times g of x. And division, f over g of x is equal to f of x divided by g of x, where g of x cannot equal 0. The domains of the sum, difference, product, and quotient functions consist of the x values that are in the domains of both f and g. Also, the domain of the quotient function does not contain any x values for which g of x equals 0. Example 1 says, let f of x equals 4x plus 7 and g of x equal the square root of x plus x. What are f plus g and f minus g and their domains? To find f plus g of x, we're simply going to plug in f of x and g of x and add them together. We know f of x is 4x plus 7, and g of x is the square root of x plus x. All we have to do now is put a plus sign in between the two and combine like terms. We have a 4x and an x to get 5x. We have the square root of x, which is all by itself, so we add plus square root of x. And then we have one constant of 7, so we just add our 7. This gives us 5x plus the square root of x plus 7 for f plus g of x. We have f minus g of x. Plug in f of x and g of x. F of x again is 4x plus 7. G of x is square root of x plus x. However, this time we're using a minus sign in between the two, so it is necessary to put parentheses around your second function. When we looked at f plus g of x, a plus sign doesn't change anything, so you didn't need parentheses here. You could use them, but you don't need them. When you have a subtraction sign, it is going to change what's inside the parentheses, so you do need parentheses after a minus sign. So next we're going to distribute this negative sign to get minus the square root of x and minus x, and then we can combine like terms. 4x minus x gives us 3x. We now have a minus square root of x and a plus 7. So f minus g of x becomes 3x minus the square root of x plus 7. Now we need to consider the domain of both f of x and g of x in order to find the domains of f plus g of x and f minus g of x. The domain of f of x is just all real numbers. We can plug anything we want into f of x. However, the domain of g of x is all real numbers such that x is greater than or equal to 0. We cannot plug a negative number into the square root. Therefore, the domain of f plus g of x and f minus g of x have to be all real numbers x greater than or equal to 0. The domain of f plus g of x and f minus g of x has to satisfy both the domain of f and g. The work for this problem is written out on the next slide, along with the explanation of the domain. And now I would like you to try number 1. Let f of x equal 2x squared plus x minus 3 and g of x equal x minus 1. Perform each function operation and then find the domain of the result. For number 1, we have f plus g of x.